I'd now like to invite Kylie Williams to come and facilitate some question and answers with the panel. Thanks, Kylie.
Okay, I bet there are a lot of questions for this particular panel. Who's first? Go ahead.
Thanks very much. I'm Julia Kramer-Bernard, lead structural geology for Anglo-American. Thanks, Kevin, and the others for their very interesting presentations. I have a question for you, Kevin, and that's around your training data. So I was wondering, are you also excluding some of your known deposits in the areas that you're looking at in order to test the performance of your predictions?
Yeah, so hold out data and test train splits and that sort of stuff. So well, I didn't get into it here, but we do produce a bunch of error metrics that are based on test train splitting. Sometimes we do a more manual holdout to see how the model performs. But overall, we're using sort of multiple simulations, sort of moving around different test train splits and then measuring the accuracy metrics.
I'm Hallie Keeble from Anglo-American, senior regional generative geologist. You mentioned your training data being like a known deposit. Say your known deposit is underneath Chilcotin basalt, and then you want to search the whole area. Is it only going to find another similar deposit under Chilcotin basalt if you're using loads of geophysics? Like, would it find something under the till cover, for example? Because you seem to have a lot of geophysics inputs. How refined is that model? Like, is it just going to find the same thing? If that makes sense.
That's a good question, tough question as well. The predictive step is sensitive to the learning points, but this is where we iterate. So we'll run a model that's going to be maybe only see the blind under the Chilcotin, and then run maybe one that's more permissive using all the learning points. And honestly, I don't know. And this is where we sort of iterate and try and test those ideas to try build up conviction then in the subsequent sort of targets that are generated.
I'm Michael Fox. I'm the owner and publisher of the Prospector News. If I go back to about 2012, we ran on our cover back then, we ran one of the very first AI mining companies that were out there. Continue to follow them, and I'll tell you, they got the same challenges in 2026 as they had back in 2012, and that was actually getting the geologists to drill the targets. So this is open to all three panelists. How do you deal with the human factor of believing the AI and getting them to drill your targets?
We use geology from the start. And so if you remember back to the image that I showed, we're simulating geological models and testing geological hypotheses. And so when we get into calls and we explain our technology, we actually have pretty good buy-in with geologists and geophysicists to go ahead and drill our targets. So a point of pride for myself and Alex is being able to convince people who are very skeptical to use what we do. To me, it's simple. It makes sense. We're simulating geological models, and now we just have to design the drill hole that's going to shish kebab all those ellipsoids at depth, and those ellipsoids represent our intrusion. You know, down the line, those ellipsoids are going to get more and more complicated and increase complexity and that kind of thing. But for now, that ellipsoid is pretty powerful, and we've shown that it works. Simple makes sense. That's one of our mantras, is just simplicity in the company.
I believe today we are able to use more data, and the more data we use, the more confident we are that our agents, the machine learning model, is going to provide some better solutions. And if we are able to ground these solutions to data, then it is more confident to our decisions. It is only about decisions. I mean, what we are doing in our daily life is a risk management. So we need to make a decision, I'm going to drill here or not. So what we really have to do is to minimize the risk there. So the more data we have, the better models we make. And if we are able to have and believe today with the agentic AI, we are able to do, go and understand the model, not just take the result, but try to understand why the model provides the results, then we are able to make better decisions and nothing more. The job, we still have the job. We still make the decisions. It's not the model that makes the decision. But we have to be able to understand what is there, to understand the data, and go and make a decision. That's all. Nothing has changed. Maybe the confidence today is better, but still there is an uncertainty.
Yeah, I guess I'd agree with that. Critically, for the real skeptics who just don't want to drill it or don't want to action an exploration program, based on some of the, some of the AI products, the journey with skeptics that I have worked with has been finding their recipe in their data. What do they believe in their data sets? And then running that forward and going, okay, well, here's what you think, here are the results, and then critically assessing those results. So that's the human in the loop or subject matter expert is driving it. What we're trying to do is democratize a lot of these tools, make a lot of the sort of AI, ML decisions in the background more automated, so that it is the skeptic geologist who's trying to run the tools. And it may hopefully less convincing, it just becomes a more adopted tool. But yeah, I agree, it's hard to, you can't, it needs to align with their business needs at their time and their conviction, yeah.
I'm actually going to build on that question with one of my own, which is what about explaining how you've come to those decisions to the non-technical people and the people who aren't management making those decisions, like the shareholders, the communities, the government? How do you explain what's in, I think you said it was a glass box rather than a black box. So how do we explain the decision making now compared to years ago when we didn't use these tools?
Sure, it's a good question. It's really challenging because you've got to speak many different languages, and being able to go in front of a completely different audience than this one. I mean, highly technical audience. I'm super impressed. This is just this is my first time here, and it's like, man, this is great. But the presentation I do here is way different than a presentation I do in front of a different audience. So, for example, on one of my plots, quantitative finance for mineral exploration, right? That's using a broad brush to describe what I did on that plot. But an investor can look at that and they're like, oh, let's buy that. It's a function of just having more diverse conversations with a diverse set of different people, and just getting the reps in, of which this is certainly part of it.
Kevin, did you want to add to that, given that Verify is very much an investor-focused? I'm putting words in your mouth, but
yeah, no, I think powerful visuals. Most people understand pictures before they understand the words, and I think it's a combination of powerful visuals and simpler language. Yeah.
And I have seen on Kevin's presentation, that he had the sensitivity analysis. So I changed my features, and this is what's happening in the output. This is really important. If we are able with these visuals to show sensitivity analysis of your data, how they actually correspond to the output, it is important. And I think we are lucky because these presentations, this slide actually relates to your question. Why? Here we have the LLM here provide the response, but also not only the response, provide the link to the data that actually lead to the response. And this is important. If we are able to have, and it is doable today. I mean, if we are talking about random forest type of machine learning models, it is very, very easy to make analysis to understand these results actually comes, there is a reasoning. The full reason can be given. And this is happening now also. It is very much slower. It is much more difficult. If you go to vision transformers that Kevin is using, it is even more difficult to understand how it's happening. But we do have tools like sensitivity analysis to understand why this is happening. And this we can explain easily. I mean, we don't have to go how the patches are working, how the latent space has increased. It is complicated for them. But images like the one Kevin showed before, sensitivity analysis, I tested this. If I am 5% error here, I am going to see 10% error there. And you have to believe that 5% is the maximum error I can have in my inputs. Something along this, I believe, can help.
Thank you. I think there's a question right at the back. Yep.
Andy Fleet. Each of you mentioned that geophysics underpins your predictions. Does that mean with no geophysics it doesn't work? But does it also mean with more geophysics it could be even better?
I'll jump in there. You can absolutely do targeting without geophysics, 100%. I've worked on projects where it was really quite thin, not very rich, but I've been flabbergasted by how much you can get out of just the DEM. Just doing the right thing with the DEM and trying to tease out. And of course, the geological map is very rich in information. They still have value, they're just discrete. And these algorithms like more gradational data. So you can still target without geophysics. I think, multi-rock property, for sure. So I think of it as not more geophysics, but more rock properties is beneficial. So my perfect combination would be, everywhere I would have mag, gravity, and some sort of EM. That'd be my perfect recipe for generalizing well. Not picking on ant. I think that works great too.
I have to add here now that we at Earth Science Analytics we are working a lot of trying to integrate geophysics into machine learning models. So actually what we are doing, we are building foundation model constrained by pin networks. So try to integrate and make a model that's able to generalize, but at the same time maintain the physics rules behind the data we are examining. And this, I believe, will be the future on this. I mean, we're going to have a presentation on the next CAG conference in June, and something that I believe will go AI and all this technology further. Always we have to think on what I mentioned before. Multimodal is the key. We should not target for a single property. We should target for multidimensional properties that are linked with geophysics. And these geophysics rules are actually constrain our network and provide even better machine learning models. Tyler, sorry.
Geophysics, very useful, not always necessary. So sometimes we'll talk to a company and they want to use 5 different layers of geophysics and we'll advise fully against it. That's just what we do, I guess. Keep things simple.
Okay, let's jump to another question. Go ahead.
You indicated that brownfields is the kind of focus of the majors and so on. And you also suggested and implied that that's the data-rich environment that is well suited to AI and AI methods. So therefore, who's going to do greenfields and how are we going to do it? That was for you, Tyler.
Yeah, that'd be too.
Yeah, well, it's not sustainable to keep on exploring in brownfield environments. And it's not that majors are not doing any greenfields. They definitely are. And there's juniors doing it as well. But it's a smaller proportion of resources than it used to be, is how I kind of read the tea leaves. So who's doing it? I think everyone's going to have to do it. But then it gets, it's a global targeting exercise. It's like where are you sort of, staking your claim. So I think, I would, we'll guess in here, but over the next 20 years, we're going to have to do more greenfields.
Okay, one more question. Yep, you.
Xiaolong Wei from UBC MDRU. So in the last sessions, 3 speakers highlight that multi-channel high-resolution core scanning data is important and useful. But I haven't seen this data used in the AI exploration in this session. So I'm wondering why, and also what's the strategies to incorporate and upskill this high-resolution core scanning data in AI exploration.
Maybe I was too fast when I was discussing about the AI images part. So where we're using cores and chips and actually go get the actual truth from the core scans in order to correlate and make the first machine learning models that actually are going to make the mapping from wireline logs to the core information. So I believe core scans is. I'm coming from the oil and gas industry. We don't have cores. We have too few. But I believe mining with a region with so much core that we have to use them at the maximum. I mean, we are lucky to have the truth in our hands. So we just need to build the commodity tools that I described before, get them into our databases, and then start working on them. Because we have the truth. In oil and gas, we try to imagine what's happening. Here we have the truth in our hands. We can see it. There's no question. I mean, the core is there. Go do the measurements, you have data. I believe we are lucky. This industry is very lucky on this.
Tyler or Kevin, did you want to respond to that question?
No.
No, that's okay. It's totally fine.
I'll say that we've definitely consumed coarse count spectral information. It does become a sort of a question of scale and what are you trying to achieve what sort of scale of targeting? Is it an inter or intra system? And I guess, you could use that sort of that rich information to better define your footprint, and then that can lead to more effective targeting. So sort of indirectly using it, perhaps a bit more. But also, not everybody has it. Like most exploration projects don't have much drill core spectra yet. Hopefully that answers a bit.
And that's why my answer is no to that. We don't really encounter it much on these early stage projects. Later stages, I mean, it's fantastic. But greenfields, it's hard to get that richness of information up front.
But Dave would like to do one final comment.
Just a comment just about the copper comment and brownfields and greenfields. We're entering a very interesting break point, if you like, because BHP reported last year that the capital cost to bring a tonne of copper into production is now the same between greenfields and brownfields. So I don't think as an industry we've quite wrapped our head around that and what it means for true long-term planning and funding exploration projects. I think it's good for us.
Okay, if everyone can join me in thanking panel number 3, Tyler, Demetrios, and Kevin.
And before we all disappear for afternoon tea, I just wanted to thank Kylie Williams very much for supporting our little event here every year at the busiest time of her working year. So if you could just join me in a round of applause for Kylie's efforts.